Okay, looks like we are live. Awesome. Back to my main tab. Wait a minute for people to start rolling in. Gotta send my message, let everybody know that it is live. Okay, there you go. There's the live message for everybody. Make sure Twitch isn't freaking out or anything. Get to see how many people roll in, but I guess I might as well start explaining some of the stream goals. Yeah, sure, let's just go with that. Okay, so just going through base goals for today's stream. The first thing that I'm going to be working on is just explaining Roc Glue. After we're done explaining Roc Glue to everybody and making that clear, the main goal will be fixing a bug in Roc Glue, because the compiler is always full of bugs. That's just a rule. I mean, I guess this is a side tool related to the compiler rather than the compiler itself. But fix a Roc Glue bug. God, can't type. To enable the basic web server platform. Oh, that's how you spell server. I can type. Okay. And then, depending on how things go with that, I'm hoping that won't be too long, and that'll be pretty quick. The third main goal for this stream is to switch over and deal with some type inference bugs, or it's not really type inference, but enable recursive types through lists, which I'll explain that later, what that actually means. But those are the three, at least, starter or main goals for this stream. We'll see how they all pan out. For basic web server and Roc Glue, I'm hoping that won't be a very long piece. The recursive types through lists, I have no idea. That could end up being a huge pain, because types, I don't really know the type system of the compiler, to be honest. I only have interacted with it, so fixing in a bug in it will be educational, not just for viewers, but also for myself. And so with that, I guess we can just jump right in and go straight for trying to explain Roc Glue. So I guess I'll start by just running an example. So I'm in this basic web server platform. And so, if I open up this directory, it's a platform with, of course, lots of different Roc files. And then it is, most importantly, it's written in Rust. And so there's a number of Rust files here. The most important thing that for us is this glue folder. This glue folder is a automatically generated set of files. And so if we come and look in here at roc function, for example, or actually I think that one's the one that's not auto-generated. So let me go to roc app, because I think that's the more important one. We look at this. This is a bunch of just auto-generated Rust that does all of the binding related to how Roc works. And so in Roc, there's going to be some sort of arrow type that contains this information. And so we can say that in this case, this arrow type is made out of strings, and then it also has a status. And that's because it's a web server. So this is like the HTTP status of this. And so we generate this. There's a lot of customization based on the different platforms, because they have different size types, things of that nature. And we just basically are defining all of the CFFI that is required to interact with Roc. And so the platform needs all of this different information, right? Here's our enum related to different types of responses, right? Is it a good request, a bad request? What is it? And so we define all of these different pieces, and this is all automatically generated. And so this is just one of the nice tools to make it so that interacting with Roc is not a big pain, right? In Zig right now, we don't have any sort of glue. And so people writing Zig platforms basically have to figure out how everything works in Roc. They have to go and define their own types. They have to deal with all of the CFFI. And Zig makes CFFI nice, but it's still CFFI. So it's not something you really want to deal with. And so overall, Glue is an amazing tool that we really need to get spread to more platforms, but that's not the issue for now. Right now, we have this web server example, and specifically, what is it? It's the roc function 88, I think, or function 88. Let's see if I can find it real quick. Why is nothing called function? Oh, it's because it's in a different file. Roc app lib.rs. Oh, thank you for the follow. But so we have function 88 here, which is just an arbitrary function. It is a closure, essentially, that Roc is returning. I actually don't know why we decided to name it 88, but I'm going to assume that there's some sort of type reason that it just happened to be like type variable number 88 in the program. But nonetheless, this is like what actually ends up dealing with calling Roc. You know, this is our actual main function in Roc that's going to be called. And so this tool here is incorrectly calling Roc, essentially. We've generated code that incorrectly calls Roc, and so if I go and I say, oh, let me try and run this example, and I think it only breaks in optimized mode just because of how the bug ended up generating, how it presents itself. But if I try running this, we can see it's now listening on port 8000. I head over to my browser, I head to localhost 8000, and we get nothing. In fact, if you go back over to the server, we get a fun seg fault, misaligned pointer dereference. Oh, this is, I think, where I saw this error that Richard was just talking about in the Zulip chat, where it was a misaligned pointer dereference. Okay. But anyways, because we're incorrectly generating how to call this function, basically we're passing the wrong data to something, we're reading garbage data, and then it crashes. And so we have to essentially just fix the generation here and make that nicer. And so to do that, we're going to just be working in Roc actually today, as opposed to working in Rust, because of how Roc glue works. Essentially, should I try to draw this up? Can I draw with Excala Draw? I'm not talented when it comes to art, but I can try this real quick. Hopefully that's a reasonable size. Let's get some text. So we have a Roc platform. Oh man, that is a weird font. And it fundamentally wants to call a Roc application, right? I should learn all the shortcuts for this. Okay, we got this. So it wants to call a Roc application. And so that's what's happening over CFFI. But because Roc's interface is a pain, what we end up doing is when we're running the compiler, so we have the compiler over here, and it has this glue function. This glue function will essentially first take in the application. It will read in the application. It will figure out what is needed, and then it will go back to the platform and generate more files for the platform. So like, we'll just go like here, you know, auto-generated Rust for the platform, right? So we'll also have auto-generated Rust that is like literally part of the platform that gets compiled with the platform, and Glue just does that. And how it does that is it ends up running a specific file that we specify, and that file, so it runs a, in this case, it runs rustglue.roc. And rustglue.roc is just a file that essentially says, given a list of Roc types, here's the Rust for it. And so that's what we're going to be working on today, is we're going to be working with this Rust glue file, and we're going to be correcting the auto-generated Rust. And so hopefully this first part is actually pretty direct and straightforward. Also, I just realized this isn't in dark mode, so I'm sorry for all you people who are blinded by the bright background and whatnot. But anyways, we'll jump out of that. No need to blind people more. Okay. And so with that, I'm just going to head over to the Roc directory and go straight into editing the glue and trying to fix it. I guess I should first actually point out more what the bug is, because that's important. Yeah, I know it can be changed to dark mode. I just kind of forgot. I mean, where's the button for it? It's probably like right up here. Dark mode. There you go. It's beautiful now, and it won't murder people anymore. But yeah, so actually real quick, one more thing to show off here. Did I keep my editor open? I did. Cool. So to show what specifically is going wrong here and what we actually need to fix. So this Roc function, this Roc function here is basically just defined as whatever the closure data is. So what is the data it's capturing that we need to reference, right? And so that's just a list of bytes. There's actually no reason for it to be a Roc list in this case, but that's fine too. I mean, a Roc list is a list fundamentally. And so if we go down and we look at where this is generated. That's the important part. So if I just go to references here, where is it generated? Yes, here's where it's being generated. So this is basically, we call a version of the main that then returns this closure that then we call the rest of the way. And so when we're calling this main to return the closure, the issue is that we basically pass it in. Oh my goodness, can't scroll apparently. Scrolling with my mouse scrolls too far. But the issue is that we pass in this entire roc function as a pointer. But that's not a pointer to the closure data, that's a pointer to this function. And so really what we need to do is request, we have to generate the correct area of data space and pass that into here. And so there's like two steps. One, get the correct size and generate the closure data of the correct size, and then pass that in instead of this. And so if we now, I guess I'll just do that. We now head over to Roc here, and what it's crates, glue, source, Rust glue. Yeah, here's our beautiful Roc file that does all this generation. So here's this Rust glue file, which literally has this function make glue. It's really high quality here. Direct naming, very clean. It literally just takes a bunch of types and returns a bunch of files. It's pretty simple. We could go into like looking at what those are, but it kind of isn't too important at this moment to see exactly how all the types are represented. It's just, tags and unions and records of data. Like, it's nothing too crazy. And specifically, one of these should be, right here, generate a function. And I guess there's two different versions. Oh, I guess if it's a top level function, we don't generate it, but the other ones we call generate function. So it's this generate function that we need to work on. And also let me get some basic syntax highlighting. Give us the Elm syntax highlighting. There's at least something. Oh, that's actually pretty disappointing in this case. Yeah. Okay, anyways. So we grab that. Yeah, so here's this generate function. And literally building these files is basically just catting strings together, right? We're defining everything, we're filling it out, and we're catting strings together. And so hopefully right here is where I will find where it generates this data. Yes, here we go. Here's this giant template here. And basically I'm just trying to change this template to be correct. And so we have closure data. I don't know why it claims this is a lambda stat. This should just be a list of bytes. And then we have how it's actually being used here. And I guess given this is just a chunk of data, it's probably more useful to correct it in the Rust code and then copy and paste it over here. Real quick though, I want to look at that lambda set variable and see what it's set to. Oh, it's just the name of the type of the lambda set. Okay, that's fair. Okay, but anyways, so we'll actually jump back to this in 1 second. Let me correct it in the Rust here first manually, and then we'll get back to it. So, as I said before, this roc function 88 here, it doesn't even need a roc list here. So let's first just correct that. This can just be a vec. There's no reason for it to be anything roc related. It's just a bunch of bytes. So there's piece one of that. Then we go back over to that use here. And it's probably going to complain at me in a number of places for various reasons. Yeah. So we come back to this use here, and we don't actually want to pass this a roc function because it is just expecting a pointer to bytes. So we can just pass it a byte slice. So I think we can just do this. So we're going to pass it a mutable byte slice in Rust. Because that's really all it's expecting. And so in this case, we are going to generate just a blank roc function. Roc function 88 with closure data, which for now we'll just make it empty, but that's going to actually change because we're going to want it to have a specific size, but that's okay. No big deal there. And so then over here, why 88? So 88, I think, comes from Roc's type system. So when Roc is going and scanning the entire file, it's like numerically numbering everything. And so in this case, this probably was function 88 that it ended up scanning. And so just to give it a unique name on the Rust side, we just threw the 88 at the end, because that's how Roc in the compiler references it. There's probably a nicer way to do this where we could, actually export some sort of naming string that's unique. But in this case, we just have the 88 there. But, it could be done better. I think really we could, well, like as long as Rust or our glue functions wrap everything in nice names, right? So like fundamentally an end user is going to see main for host, right? So they don't care that under the hood it's this Roc function 88. So as long as we wrap it, I don't think the names really matter because it's all auto-generated. But they still could be nicer for debuggability purposes. So yeah, and so now here, instead of just taking this as a pointer, we just need to do what? Change this to the actual underlying vec. Oh wait, it's called closure data. And then, of course, it has to be mutable. And so that now is no longer complaining. Now, the other important thing, though, is there's another function here that we actually need to call. I think it is just Roc for host 1 size. I'm hoping that's the right name. I'll have to double check that later, but not important yet. And it's a simple function. It just returns an I64 of the size. And so this will tell us how many bytes the closure capture is. And so that's how many bytes we want this to be. And so we can just do something simple like vec with capacity, I think. I wonder if I can just like do a defaulted back. Like, is there a vec? Can I just start with resize essentially is what I want to do. But anyways, with capacity, and we're going to grab the capacity. Let's move this in here so we can grab the capacity first. So the capacity will just be this other function that I just added here, the size function. And then we will convert it into a usize here. I don't know why Roc exposes an I64 here. Yes, this file is auto-generated, what I'm working on right now. But I'm editing it directly because when it comes to like actually changing the final thing, I'm gonna like copy and paste this in and then just tweak it a little bit. And so it's easier to edit this directly when I have Rust complaining at me and telling me what I'm doing correctly or incorrectly. And so that's just what I find the easiest way to do this. I know what this manually should be, even if not everybody does. Okay. And then the other thing is we don't just want it to have that capacity. We also want it to have that like be 0 initialized. So we just resize that to, okay, sizes first. So capacity and all zeros. So we'll just zero this out. I don't know if zeroing it out is strictly required, but it'll always be correct. So I don't really mind. And now this should actually be getting called correctly. So we're initializing that vector. We're giving it a correct size. We're zeroing it out. And then we're passing that in, and Roc is writing to that. And so this is what we actually want that function in the other file to look like. Of course, we're going to have to fill in pieces. Let me actually just open that other file from here. It probably is going to be easier that way. So Roc creates glue source, and then it is Rust glue. And then what was it? Roc generate function? Yes. Okay. Okay. So yeah. So now, instead of me like trying to manually edit this and having a big pain manually changing this and then having it regenerate and going back and forth, I can just edit it here. Oh, though this is just the force thunk side of it. I need the other part of it where it's getting called. I need to change that. I do actually have to update this side too. So like, first off, this right here can just be evacuate. That's what we just changed it to. And so that's just fine. I'm gonna come over here. I have to figure out where this is generated because it's in a different spot apparently. I guess I should test that that works too, to be fair. Make sure I actually got this function name correct, which I can... Oh, I guess I still have a mistake. No more assume init. There's nothing that's uninitialized. There we go. Is this not FFI safe? It's not. Okay, I need this to be a pointer then. Does that autocast, or do I need to tell it to be a pointer? I need to tell it to be a pointer. Okay. As mute pointer. Okay, now it should be happy, right? Oh, yeah, of course it's not a pointer to a slice anymore. There we go. Now we have the types that are correct. Okay, so this is, I think, the only change in this spot that we've done so far, but there actually is another change that needs to be done here. So I might as well do that in the Rust side first and then catch up with that. So if we again go to function 88, oh, right here, just go to its definition. It has this force thunk, which is where it's actually called. And the closure pointer is actually unnecessarily complicated and basically incorrect because it just should be self.closure pointer dot as mute pointer, like we, or is it just a regular pointer? It's a mute pointer still. Okay, there we go. Why is this unhappy? Oh, because it's not closure pointer to closure data. Self is not declared as mutable. Well, then we shouldn't be returning a mute pointer to self. Self should be mutable. It's all a lie. We're actually should be consuming and destroying self in this case. You can't actually call one of these twice currently. But anyways, this is fine. So now this side is correct, and so that also needs to change on the Rust side, this caller function here and not generating that other piece. And so I think that's just right here. That's what I'm looking at right here. And so I need to actually match this template instead. So I think really that's just this little line. So that's pretty easy. Let's just change that out and then get rid of this closure pointer, and we made it mutable. And the reason that the closure data needs to be mutable is because you may have something that's ref counted and we have to update the ref counts that are in there. We might have to free memory, things of that nature. And that's also why they're currently not callable more than once. To make them callable more than once, we need to expose another function so that the platform can increment all the ref counts in the closure capture data. And since the platform currently can't increment the ref counts, the data is all going to be freed, and then they're just going to be passing trash data into Roc, and it's going to break things. But yeah, so this is half of the update already. I just need to figure out the other half of the update, where that is, where we're generating. What's a good word to look for so I can find the correct thing? Oh, I just lost my Roc function 88. Oh, I'm in the wrong file, that's why. Okay. Okay. Cool. So yeah, let me find that real quick. So the other function that we were editing was this main for host function. And so I need to figure out where this is generated. And I'm not actually sure, but I probably can look for this little tagline right here, exposed generic. And that may be enough for me to find it because it is a pretty key name. Let's see if that works. Oh yeah, it's literally right here. Perfect. It's literally right before generate function for some reason. I changed scenes. Oh no. Oh crap. Apparently I tapped a button and changed scenes. Good job, me. Hopefully that didn't disrupt too much, me just working with a BR back screen right there. Just talking and letting everybody start a BRB screen. I guess I need to be careful with where I type. My change seed buttons are basically right where my right hand is. It's like control and then a letter. And I guess I accidentally hit that at some point. Quality. Okay, sorry about that, everybody. But we are back to the stream without me being in the wrong scene. And so this is the other part that I needed to update right here. And this is just updating those caller functions as I mentioned before. And so that was this other change here for Rust. And And so again, we're mostly just going to be copying the information. The extern signature is generated before this. So let's just hop on up and figure out where that's generated. Oh, and we can set this back to Elm again. Get at least a little bit of color. Some little bits of color. Yeah, so the extern signature here is where they have this type here that's just is unnecessary. We don't actually need to use the type here because it should just be our single, or no, it's here. This return type is incorrect because it's just going to be a pointer to bytes. Oh, where do I check that? Where is that actually being generated? Because currently, what is it generated as, actually? What was this before? It was the pointer to rock list? Not actually sure. I guess I'll have to come back to that one. But we can change this other part for now. So this other one is going to be the size function, which again, I'm hoping the name is correct. I think it's just size, like that. And I can double check it later. But its signature is known always because it's always the same signature. So I don't have to mess with it at all. And then most of this, I think, can just be copied right on over. Tabbed in an extra time to match what's expected. Oh, we have to generate the name, though, when we call this, because it's not guaranteed to be main for host. Okay, so that's just the name there. We're calling that function. We're generating the vector as expected. We're setting its capacity and filling it with zeros. And then we had to change this as well. It's not just ret as mute pointer, but it's ret closure data as mute pointer. I think besides maybe some small other changes, this is actually most of this change that should fix it. Before I run glue, though, let me actually just run this web server and make sure that I actually fixed it correctly. So if we run this web server again, oh, I'm in the wrong folder. Roc web server folder. So if we're running this web server again, it's going to rebuild the platform automatically. And we see that I got the name wrong. Okay. Luckily, there's an easy way for me to get this name. There is this file that was generated. That's the LOVMIR for our Rust stuff. And if I just search for what it was, main for host, and I come through here, the size function should be right here. Ah, it's exposed size. That's pretty simple. So I just missed that. And so now if we go back to this Rust here, and we just correct the name. Oh, apparently it didn't copy. That's fine. Let me come down here, also update the name. So hopefully that's all we need. Oh, without debug. And so I think this should be enough that the web server launches. Yeah, running program perfectly. And so if I did this correctly and we're setting these bytes all correctly, if I go back to our browser here and reload, it at least shouldn't crash. I don't know what the program's supposed to do right now. Yeah, no crash. It doesn't display anything, but it doesn't crash either. And so that is fixed. It recognizes that it had a call to its main path. And so that should all be good. And so assuming Roc Glue is fully updated here, which I think it's not. I think there's one more thing I'm going to have to change in a minute here related to the external signature that's exposed by this generic function. But besides that, I think that the Roc Glue is mostly updated with just those little changes. And so we can actually run glue. Let's see if I have the command saved. I don't. Okay, so let's see what it takes to run glue. So glue has a few different things that go into it just because there's like a larger spec. So first is the spec, which is the file we've been working on. Is it worth writing safety comments near the unsafe block? Yeah, I think in general, safety comments are a pretty good idea. In this case, this file is just totally riddled with unsafe, and all of the unsafe is just to do CFFI. So I don't think it's as valuable in this file specifically, because literally every unsafe block is just calling roc functions, right? So it's not really like the entire file, the unsafe is exactly the same. But I do agree, like, that overall it's a good idea to do it. And like I could also be a little bit more proper and like scope my unsafe better, right? Like technically you can do just an unsafe right here. And then I could do a second unsafe just around this right here. And then technically ret doesn't need to be in the unsafe either, and then that goes away. Is that correct yet? I know it's correct when the auto formatter works. Okay, I don't quite have it right. Oh, I'm missing a bracket. The easy things. Yeah. So technically I could write it like this and there'd be less unsafe blocks, but honestly, I don't think there's that much value when all of these are just FFI functions, right? Like you always have to use unsafe with FFI, and whether there's a little bit more in the block, like I think this is slightly less readable despite being, I would argue, more correct. Also, Luke, thanks for the follow. But yeah, even though this is more correct, I don't, and like, you know, again, commenting also is more correct. I don't think it's really valuable here in this auto-generated code. But yeah, let's work on running glue now. Okay, so roc debug glue. The spec is the file we've been working on. So roc creates glue. That's not how you spell glue. Sourced Rust glue. Then next is the output directory, which in this case is going to be, I think, platform/glue. Yes. Okay. And then finally is the actual roc file. And I think it's the platform's roc file. So it should be platform main.roc. And this should regenerate everything and overwrite all of the changes that I just made and let me know that I had an error. Lambda set's not used. Oh yeah, because I stopped using it because it's not needed in this case. Lambda sets are always, in this case, just a vector of data. Where the heck was that? That was somewhere down here. Yes, this lambda set variable is not needed because we're not doing anything with all of the exact information about it. We're just turning it into a list of bytes. So what does it matter, you know? Okay, so that regenerated. Let's see if it regenerated something correct though. So if we reload this, we have an empty file. Oh, that's even better than I thought it would be. Let me see if that just generated in the wrong spot. Did I specify something incorrectly? Let me generate to a temp directory real quick just to see, which is probably what I should have done in the first place, you know, generated to a temp directory so that I could like see what it's outputting before I overwrite everything. Web server glue, because I'm pretty sure I already have a temp/glue directory. So if we regenerate this again, go to this web server glue folder. Okay, so it's generating an app folder. It's generating a std folder. That all looks correct. Did it just like... Oh, but the lib file is empty. Oh, because it's been updated. The lib files are now split into multiple sub files. Yeah, okay. Oh, that's why it looks weird. Got it. Okay, so that did generate correctly. I just have to look at one of the specific files. So I guess I'll look at the ARM64 version. Sure. So if we look at this ARM64 version, I wonder if it's still going to be roc function 88. It is still roc function 88. Interesting. And we have our first force thunk function, which looks good. We have the closure data coming from the vector and no extra thing here. And then we go to the other uses here, and in main for host, which is the main place that it gets used. Ah, this is still incorrect. So we need to correct this to just be U8 instead. Yeah, we used to have generated messages. I don't know what happened to them. I think when we split it out onto multiple files. Oh, it is. It's right here. It's just not in the lib file. That would be good to add. Huh. Yeah, we can do that as well. That's a good idea. Guess it just got missed for the lib files. Okay. Let's not sidetrack on that just yet, but I will add that afterwards. Let's first get this type correct. Am I in the right spot? Okay. So that's something up here. No, I'm now totally somewhere else. Oh yeah. It's here where it's specifying the return type, The return type it thinks is a roc function, but it shouldn't be a roc function, essentially. Oh, this is specifically only for the extern signature for a roc function. Okay. Where does it define what ret is? Ret is the type of the return type. Yeah, so I guess that's just wrong. Ret is no longer that. That feels wrong to just remove that. I bet we need to do something different here. Because I think this is only the case if we're returning a lambda set, that it's not the type of the return type. And whenever we return a regular type, it is the type of the return type. Let me go look at the definition of that return type. Oh, I don't have my autocomplete because I'm in the wrong directory, right? So roc creates glue. Yeah, there's this roc type folder, I think, that has all of our roc types in it. No, that's mod.rs. There should be a roc file with all these types. I don't see it immediately. Oh, it's because it's in the platform directory, right? Platform, yeah, here we go. Types.roc. So if we go to the roc function here, rocfn, is that here? Roc shape, targets. It imports type ID and target. I don't see the actual type definitions here, though. Which file has the actual type definitions then? It's not going to be file.roc. I guess it could be typeid.roc. That seems weird. Oh no, type ID is just a number. Okay, so that's definitely not it. Been a while since I messed with this stuff. Ah, it's the shape of the data. Apparently that's what we named it. Okay. But anyways, we should have roc function here, which is just a roc function, which has a name, externs, a lambda set, a return type ID, which just links back to a list. Yeah, okay, that's fair. And I think only if the return type is a lambda set, we actually want to change it to this. I'm trying to see what that would be, though, in this list. Is lambda set in this list? Unit, unsized, function. I guess it would be if the return type is a function, we want to overwrite it, how we print it. Let me see. Yeah, it's just going to be if the return type's a function. So if we pop back over to our generation here, because we don't always want the type name. What? So when the return type is a function, what did I just do? That's not what I want. So when it is just, I think it's just going to be rocfn, and we don't care what the body data is. Or no, sorry, it was function. With the data being rocfn. So when the return type is a function, we actually want to just specify that we're returning a U8. It's going to be a pointer to a U8 because it's a list of bytes. And actually, let's merge those onto one line. Versus all other types, we actually do put the proper type. Oh. And then we'll do, hopefully this is adding the right type of tabs. I guess that's something I should have checked before doing a bunch of tabs. But if we do that, I think it's now correct. That means that, wait, we're already in a roc function branch. Oh, I'm silly. We're in a roc function branch. This is a function. Oh no, it's when a function returns another function. Yeah, no, I think this is correct. Gotta love typing of things. But I think this will generate what I want it to generate for functions. Though I also just realized that I think I did something wrong when I was changing this, because I assumed that everything is returning a lambda set. Not when I changed that. When I changed this here. Oh no, this is with closures only. Okay, this is with closures only, so that should be okay. Is the roc glue generated artifact expected to be edited? No, it definitely, the goal is to make it all automatic, and once we have this all set up, there's a nice safe interface for people to just use. And so, yeah, you'd probably put it into your source control. That's definitely what I would advise, because then someone can just check out. They don't need to run rock glue to generate anything. And it also makes sure that like you don't get messed up because someone updated something, right? Like you want it checked in so that if we update rock glue, you choose when to run it and add it to your application, because there's a chance we update rock glue and add a bug, right? And so I definitely think you want it checked in to keep that sort of protection from it. From when we make bugs, I guess is probably the best statement here. Okay. Anyways, I think this should now be correct for the rock glue. So we'll generate that again. If I can type, what's the issue? Ret is a nat. Oh, it's the type ID. Yeah, that's fair. It's not the actual type. It's just the type ID. Where was that? That's up quite a bit. So I probably have not just type name that I need. I think it was the next one up, right? This function here. But I have to basically get the actual type. Real quick, let me look at this. If I do type name equals. Okay, so there's a types.shape function that I want to be calling. That's essentially what I want to call is this part here to get the actual. Oh wait, no, that's gonna give me. Yeah, no, that'll get me what I want. Yeah, cool. So we come back here, and instead of just using ret directly, oh, that was not where I wanted to paste that. We take this, and that's the ID. Okay. Man, okay, I need to change where my hotkeys are, is what I'm learning. Because that's too easy to hit. Man, that's a pain. Okay, don't put your hotkeys right under your fingers so that if you accidentally press Control in a letter, it immediately changes your screen, is what I've learned. Oh, man. Gosh, stupid things like this that just like show the quality of the stream, just, you know, right down to the gutter where it belongs now. Okay, anyways, I think I fixed that, so it'll actually be the type. Yeah, okay, we generated something. Let's look at what we generated. Go back to that arch64 file. What was rock function 88? So we already said this part was all correct, but I think it was the other use. Yeah, this main for host. Yeah, so now it has immutable U8, which is the important part here. And that's just an exception for rock functions specifically. We don't actually want the type to be returned as the function. It's just the closer capture data. Okay, that should be good. So let's commit and overwrite the real stuff again and hopefully not mess anything up. So we overwrite the real stuff, give it a second to run. We can reload everything here. Lib needs its auto-generated line still, but we come over here to, oh, the arch file. Let me close some of these. Okay. So now we search rock function again. We go to the other use down here, and we should see that there's no type issues, hopefully. There's still a type issue. What's the issue here? That's an outdated issue. Restart my LSP, see if it corrects its errors. Yeah, there we go. Interesting, pressing Control D and Control F. Yeah, I don't normally have that happen to me, but I totally get the pain. Oh, it's because my keyboard layout doesn't have D and F next to each other. But I think I used to hit that a lot maybe 10 years ago before I changed my keyboard layout, but not so much anymore. D is like an F or a couple keys apart. But now I know how easy it is to hit Control something though and just change your scene. Anyways, I don't think, oh no, it still says there's one error. Let's see, what's the one error? Type defined here, improper C types. Apparently we're telling, I don't know. That seems unimportant for now. What keyboard layout do I run? I run Colmac. I'm one of those weird people who learned a different keyboard layout. Me and a friend in college both basically just were like, we're going to learn something better. And like, you know, at the time that seemed to be the reasonable, like large enough keyboard, like popular enough that it's usable on a lot of systems, but also not too hard to learn. And one of its main metrics that it reduces is like how far your fingers actually have to move. And it helps like promote rolls. So like when your hand kind of does like a twirl type movement from like one finger to the next. But I like it overall. I'm not a fast typer, so like, was it worth it? I don't know. But like at this point, it's ingrained. My QWERTY is really poor. I've been doing it for so long. But is it a gain? Maybe. It definitely should be better for arthritis, thinking stupidly long term, because your fingers just don't move nearly as much. But there's no statistics or anything on that. So like, how true is that? I don't know. All the world's fastest typists use QWERTY, so you know, I don't think really what keyboard layout you choose matters too much. Like you can have the really pessimized QWERTY keyboard and still do just fine. Anyways, I think this is generated correctly, assuming there wasn't any other bug when we updated. So let's actually try to run this again. Let's just run it directly. Examples, main. And see if the compiler complains at us at all. Oh, nope, there's definitely something broken. Associated item not found. Method not found. Okay, I bet this is because of the new lib stuff that we just imported. So it wasn't even something that we specifically broke. Oh, this file was also manually modified. I have to blame Richard for everything. No, just kidding. There's this extra, I think, Roc function library that's also in Glue that Glue doesn't generate that I think might mess up some stuff. That's a lot of errors that are not convenient. It's basically just not finding something. Oh, you're not the one who added? So what is this, Richard? Like, did you not add the platform Glue? There's this Roc FN folder that Glue doesn't generate, but it's there. And like, I just don't know what it's for. It just exists. I'm assuming that was manual edits of some sort, but I don't know. Oh man, anyways, we can try to fix all these other errors too, see what's going on. So apparently transparent types aren't FFI safe or something, or like whatever's in the U1 type isn't FFI safe. Well, this will be a wide detour if I decide to fix all these things. Let's see. It's a tangent not worth going into now. Okay. I mean, besides the fact that it kind of blocks me actually testing to make sure my fix works, but the fun of all of this. Okay, Roc app is apparently not exposing a bunch of things that it should, is the root problem we're seeing right now, though. Interestingly enough, it exposes method. Just not all the other things that it's supposed to expose. That's really funny that we got one out of 5 exposed correctly. Let's just real quick see if there's something obviously wrong here that's doing that. And if not, so like we have all of these, they're all just directly re-exporting, and they all re-export everything verbatim. I'm on ARch64, so if we come in here, everything in here should be exported. Do we just not have a Roc response? We don't. Or was it called Roc response? I thought it was. Let's just search response. No response either. Well, yeah, that would do it. They just don't exist anymore. There's request right there. What? So we have no response, but we have a request? Wait, what does main for host do then? What does this return? Oh, it returns a U1. That's what broke. It's now returning this U1 thing instead of the request. And this U1 thing is not useful at all. Yeah, this is a big tangent. I wonder if that's worth trying to fix at all. I don't even know what would have caused that to generate. I wonder if there's something wrong with the Roc main that's causing this. Real quick. Oh. If we go to the main real quick, just double check this. We're actually importing the response and using it, right? Is there a response in here? There's no response here. Is that related? We might need response there. What were the other missing things? Oh, we'll start with just response and see if that fixes it. Okay, so rerun glue. Generate when we actually have the response existing. And then we will rerun the program. Okay. So yeah, not found header, but did we find response now? Yeah, if you import response, you can refer to it directly. So that suggests that we actually found response. Okay, so I think we're just missing things in the output, and so the glue's like ignoring them. Okay, so we need the header as well. We'll throw that down here. Oh wait, no, header's up there already. Rip. Trying to think what else there might be that we're missing here that would cause this to miss methods. Where does header come from? So we have request and response. Let's go to response, which wasn't generating. So we have a response, which is a list of headers. Yeah, that all makes sense. I guess, Richard, do you have any ideas why glue is more broken? I guess this is a lot more updated modern glue overall, but I'm just kind of curious if you have any insight into it missing a bunch of types that I guess used to be generated. Let's see. Also, did me changing that update this at all? No, it didn't. It's still just this U1. This should be the response type. Okay. I think because I don't want to rabbit hole into glue for too long, I'm probably just going to take my current fix that I'm pretty sure is correct and save it, and then later come back and look at this much bigger glue rabbit hole of it totally just ignoring types and generating whatever this is. You know. I don't even, what even is convert infallible? Like, I don't even know what this Rust type is. What is this used for? I've never seen it before. Okay, where do these docs start? The no error type. Oh, it's if something can't fail. Okay, yes, that makes sense. Yeah. It's meant to be like a, oh, we return a result, but the result is either X or, you know, an error. But yeah. Really weird that response just doesn't generate at all anymore. But yeah, I'm not going to deep dive into that right now because I just think it's a much bigger rabbit hole. And instead, I'm going to continue on to the next topic, and I'll conglomerate this Rust glue stuff. Let me real quickly make a commit for it. Little sad not to be able to fix it, but I don't want to deal with that much larger thing. Oh, not to this platform, to Roc itself. So we made the return type of functions be a U8 because they're a closure capture. We then updated it so that we actually are calling the size function and using the vector correctly. That looks good. We don't need this lambda set anymore because we're just using the closure capture U8s. And then we updated this also to be the closure capture U8s. And like I know Rust was checking all that code fine, so I'm not too worried about it. We'll just make a quick, we'll call it what? Glue closures. We'll just make a quick commit and I can clean this up later. All right, I already added things. So corrected the closure generation or closure Rust glue. Sure, that's not the best wording, but works well enough. I failed. My tea here is cold now. I should have drank this sooner. Soul slutes? What? Absolutes? I'm assuming that's supposed to say absolutes, but I don't know what it means, or what it's referencing. Oh, I guess real quick, I can also add the generation text onto the library, maybe. Let me at least see if that's an easy thing to do. Because one of the files we add should literally just be, and we may just import it real quick. Do we have like a generic lib file that we import? We do. This lib.rs file, which, oh no, that's the std lib. Okay, that's different. But so this is us building that library file. We're just concatenating all of these together. Oh, and so we just need the mod file content just needs a, warning message or whatever. Do we have that as a variable? I don't know how to search for emojis. I think it's a generated code in the middle. Yeah, let's see if generated comes up. Ah, here it is. Generated code. Yeah, okay, it's just file header. Let's just throw the file header into there, and that will also fix this. Oh, I misspelled closure. Rip. I'll have to correct that at some point. But yeah, so this is, we can just put the file header on these, and then we'll have everything we need for that. And then it'll have all its warnings. And I just put a warning up here, didn't I? Did I just, oh no, it's just my renderer being stupid. Cool. Okay. Make sure that it at least runs. I'm not in the right folder again. Let's just do it with a... so what? We'll just throw it in temp for right now instead of editing everything. So /temp, and then this is Roc web server platform. Okay, so that should work. Okay, cool. We generated the glue, and we can quickly just look at that. And it was just the roc app lib.rs, I think, or mod.rs. No? What is this file? Oh, source. Yeah. lib.rs. There we go. It now has all the standard allow everything warnings and the generated code message, which I am fine with all of that being added. I see how I mistyped closure. Let's just do a quick amend. Fix that. Got it. And then we will add this, and that's all that's needed. So add the file header. There we go. No. Okay. Okay, and so I wanted to now switch to a totally different set of things and errors, which is enabling recursive types through lists. And I have no idea how easy or hard this will be. I don't work with the type system in Roc a lot. I just want to fix this error, so I'm going to try it. This could be me like digging into something and suddenly finding that the type system is way more complicated than I think. Or it could be like some super simple, like, oh, just an extra case in a match statement in Rust. We'll see what that turns out to be. But fundamentally, here's the issue. I want to be able to define a type that's recursive, and Roc allows that, but normally they're done through essentially tags. And so you might have, you know, node, which has, you know, it's either a branch, which contains another node, or it's a leaf, which contains a string of data, right? And so that roughly is what a tag would be. And so that's something that's recursive. But what we want to be able to do is take that a step further and just literally say it contains a list of nodes here. And actually, this one right here would still work. Where we get a problem is when we remove the tag. What if we just have something that's recursive with lists? So if we had our node type was instead a structure of some sort that had maybe a data, which is a string, and then we just had a list of nodes, you know, children. And so if you do this today in Roc, it will break. In fact, I should be able to just, if I do roc REPL, can I just throw this in the REPL? Will that break it? I think the REPL may not evaluate it. It may, yeah, it's gonna, interesting, the REPL doesn't care. But definitely regular stuff cares. But let's see, if I do x is a node, and then we just say x is, we'll just put it as an empty string in an empty list. Is this going to work? If it works in the REPL, I'll be extra confused. To do, provide more context. Well, it fails in the REPL too. Wait, let's see. Let's return x here. Yeah, okay. It fills in the REPL in the most useful way. Provide more context. I guess I can put it in something real quick. Let me go over and actually add this just to the hello world example. Kill this and open here, and we'll go just to hello world. Do I still have it copied? I don't. And we'll actually simplify this to the most basic form of this type, which is just a type like so. It's just this like uselessly recursive type, but I should be able to have one. So if I say x is x is a node, and I just say x equals, you know, empty list, and I theoretically could put another empty list in that because that is also a valid node, you know. But this is the bug I want to solve, is enabling this, because once we have this enabled, there's a lot of cases. There are a lot of cases in this where these sort of recursive types just come up naturally, where you have a list breaking your recursion. And so you end up I'm having a bad time explaining this. But basically, this comes up very commonly where instead of using a tag, you only have one type of recursion. It's always through a list of children. And so any sort of tree that's built with a list of children, you'll run into this issue essentially. And in Roc currently, you have to add all the wrapping with tags, but they shouldn't be needed. Hopefully I can get the real error now if I just run that. Sure. So if we run hello world, yes, this is the real error. This is what I'm trying to fix. So it just says that it's recursive in an invalid way. But this should be valid. Like, there's nothing wrong with this type. The reason that you can't have certain recursive types is because they would basically become like a infinitely big type, right? It's if you like keep putting the recursive type into it and you're building something up, you end up generating an infinitely big type of that recursive type. But the list actually breaks the recursion because a list is a pointer. And so the pointer separates all the sizes and makes all of this work. And so this should be a valid recursive type. And so that's what we're going to try to fix here. And we're basically going to start with this error message and work our way backwards, and hopefully it works. Probably can just start with self-recursive in an invalid way. Let's see if that comes up. Perfect. It comes up in lots of places. Yeah. Okay, so these are all example errors. Cool. But so here's the function that is generating this error, cyclic alias, and we're just going to work our way backwards to try and figure out where it was called, like what caused the issue. So I have to wait for the compiler to compile so I can get my my type inference and my language server working. I believe in you, computer. You got this. Compile faster. Maybe? No, it doesn't want to give me type inference. Okay. This is when the fallback of just searching something is often better. Okay, it's only used in a couple places. Mark cyclic alias. That's probably the important part. Yeah, I bet this is the important function. Let's see, where are we? So we're in canonicalization, which makes sense. That's kind of where we figure out a lot of things and make sure the IR is valid. This is a very long function. Where does this start? Correct mutually recursive type alias. I don't know if this is necessarily where we want to be, because we want to like stop it from noticing a type alias. We don't want it to have to correct said type alias. Where else is this used? So this is just used in two spots, and I think they're in the same function, actually, just a little bit apart. Okay, so in that case, I think we still have to go even farther up the chain and essentially follow that next link up, because we want to go before we're even correcting it. We want to say that, you know, this shouldn't be considered mutually recursive, I think. Though it may be that correcting it is saying, oh, this list breaks the recursion. So this may be the right function. There's a chance. Not fully sure yet. Do I have my... Oh, I have my language server working now. Cool. Okay, now that we know the alias dependency graph, we can try to insert recursion variables where aliases are recursive tag unions or detect illegal recursion. Oh no, this does sound like the right spot. So we just built up basically a graph of all the important aliases and information. But we now need to correct it. Okay, so this is probably the right function. So if this is the right function, the question is, where does it figure out tags and do the looping? And again, as I said, this is 100% new code to me. I have not dug into any of this type of stuff, and most of this type stuff is done by people in the Roc compiler that are much smarter than I am. It's all just magical theory to me, so I may just end up getting stuck here. We'll see. But it's always good to try some things. Gotta love the fun of like what a type ends up looking at, like cons nil, cons nil, cons b, cons a. This is the stuff that we have to unwind that get generated by users and make sense of. Something that ends up turning into this giant recursive list nonsense. I like arrays. I don't need lists. I like simplicity. But I guess I do use recursive types from time to time. Instantiating the aliases, cycle counts. Does any of this have any specification related to tag union specifically? That's the real question. So I get this is self-recursive variable, which comes from looking at cycles. Okay. Trying to figure out where this actually is like looking at the actual types. Like we see a lambda set variable, sure, but where do we actually dig into what the types are here? I feel like there should be some giant win somewhere that's basically, or match statement somewhere that's like, oh, if it's this type, do this. If it's that type, do this other thing. Because we already have a bunch of cycles here, I guess, technically, which we define as their own groups. I might just have to debug print a bunch of stuff to start figuring this out. Yeah. So we have symbols and aliases. I'm assuming an alias is just like a pointer. Oh no, it's a lot of stuff. Okay. And we of course have our giant variable store. Real quick, let me go back up the chain just to double check a little bit more. Okay, so if we go farther up the chain, we're defining aliases, opaques, and abilities. Canonicalize alias may also be useful here. Oh, I'm in the BRB screen again. Yeah, this is definitely something I'm going to change my hotkeys for later. 100%. In fact, why don't I just do that now? I'm going to just turn off those hotkeys and not murder my stream all the time. Hotkeys. Where are those? Hotkeys. Delete the hotkey to switch to the BRB screen. Gone. Delete all of these hotkeys. They are just problematic. Ugh, that's sad. I will need to find hotkeys that don't break everything. Okay. Sorry for all of the terrible screen stuff. Ugh. Okay, those hotkeys are gone though. So now if I tap these buttons, nothing happens, and I shouldn't murder myself again. Screw everything else up. Okay. Anyways, where were we? Canonicalize aliases, and then how does this canonicalize an alias? It's dealing with annotation, so like the actual type annotation, sure. Looking at a bunch of variables. Types are opaque or structural. Oh boy, yeah, this code may be beyond me. We'll see if I can find the specific spot that I want to update, because I'm pretty sure this is going to be like a surgical, relatively small update. And so I get the feeling that I should be able to find what the heck is going on and correct it. But it's mostly going to be somewhere where we're looking at all the different types. Like, so this is looking at functions and applies. Does this end up looking at lists? Is that one of the types here? Tuples, yeah, list should be somewhere here. Where is list? No, lists don't qualify here. Oh, these are all like aggregator types, I guess. Tag unions, records, tuples. Huh. Surprised lists don't qualify here. Can we not have a list in a type annotation, or is it under something else? Yeah, I guess type annotations don't include lists for some reason. Applying a type to some argument, functions, bound variable, inline type alias. Oh, as a list, or cons a list as a list. That's, yeah. Chat's gonna just be watching me struggle because this is the hard part of the compiler, and I'll just stare at different things. But okay, so I don't think canonicalized alias is what I want. I think it is in this other function, technically speaking, but I don't know how I will dive into that. Because it is a mutual recursive alias that needs to be corrected. Maybe I can just debug print some stuff and that'll give me some ideas. Let's just start with that. Let's just add the simple original aliases, debug print. And see how that ends up going. Let's just throw a window under here. So we go back into Roc. And we're just going to run examples hello world, because that has the error in it right now. But if I at least can understand the data, I'll have a chance at figuring it out. So sometimes just dumping the data is the best way to dig into a function. Okay, we've dumped the data. Oh, that's a that'll be more useful. Okay, so what do we have? We have this node type. Okay, so the node type is an alias, and oh yeah, it has a type of list node. So that's the important part here, is we have to like recognize this list piece and say, hey, don't mess with that. It's correct. It's valid in a way. So this does look like it at least has the information I care about. Where does that end up coming up though? So that ends up being, on the alias, it's the alias type. So I guess let's go look at where types are used. So we have the alias here. We get the reference symbol. So we're going through all of them. And we're just marking something. Oh, this is marking connections in a matrix, I think. I think we're building a connection matrix to figure out cycles. If I'm correct about that, let's see. So we go here. Let's just dump all of the referenced things just to see what they are. And let's also dump the type. Let's just do that here. So if this is just making a matrix and then walking it to figure out recursion, can I not debug that for some reason? I just put it at reference here. Will that make it happy? References, always the solution to debugging in Rust. Okay. Stupid language server. Be faster. This is where compiling will really be the slow part, but hopefully this ends up running pretty quick. But if this is correct, then we're just building like a connection matrix. And if this is a connection matrix, we just need to say, oh, it's a list. Lists always break the connection matrix. I'm not 100% sure that's what's going on here, but that's my rough understanding of what's going on here. So we'll see in a minute. Okay. So here's the alias type. We have our list, and we can see it references list and it references user app node. And so I think this symbol function, we need it to ignore lists essentially, which I'm not actually sure what a list is stored as. I guess this might be a tuple given it's in parentheses. because it goes into this helper function that I'm at here. Oh. Yeah, that literally just jumps into a recursive helper function that basically is managing its own stack of pushing all of the things that it references on onto the stack and then recursively calling itself as needed. So let's throw another debug in here, just on this value that's being matched here. Because I still don't fully understand what a list is in this thing, because it's not a tag union, it's not a record. I guess this might be considering it a tuple or an alias. That sounds a little bit weird to me, but if we can get a little bit more debug info, we might have a chance of correctly solving this. Okay, so we'll just give this a minute though. If that ends up being correct, we probably just need, like, I don't know if I can edit the symbol help function because it probably needs to get all symbols for other use cases. Where else is this used? I'm assuming this is used in a lot of places. No, my language server doesn't want to tell me. Probably because it's building that over there, and so they'll... There we go. Oh, it's only used in 2 places, and one of them's the definition. Okay, so I totally can just edit this and say, hey, ignore all symbols that are within lists, essentially. Okay. So we care about, when we get to this type, man, we really spell type in fun ways sometimes because because I guess Rust uses the word type. You can't use it. So you have to come up with all your creative ways to spell it. And I like how we use different ways to spell it. Okay. Oh, the debug information doesn't actually print what it is. Of course not. What is this? I guess it's a tuple. Let's just pretend it's a tuple and see if that's correct. Yes, that's a beautiful spelling of type. I like it. The fun of debug doing pretty printing. I guess I could also just print without the pretty printing, and that would potentially work. But I'm pretty sure this is a tuple, and so I guess if I just need to check if a tuple ends up being a list. But I'm not fully sure on that, and this definitely feels like it's going to be a little jank, but it might work nonetheless. Oh, helps if I type correctly. Rust, you knew what I needed. Why didn't you just add it in? That'd be convenient sometimes. Like some of these trivial errors, like, you forgot your macro invocation. It's like, yes, I know Rust, but it's unnecessary. You could just add it, especially for some debug build or run or whatever. Let's see if this is actually a tuple, if we get an extra printout here or not. I don't quite understand this representation. Like, why would list be a tuple or something of that nature in this representation? I guess that's one other thing, is I could really dig into the type more, like look at this type variable, look at how it prints things, and then I could get things more correct. Is list a tuple? Was I correct? It's not a tuple, it's something else. Okay. Where's their debug printing? Let's just go to the debug printing. Because it doesn't derive debug. So, oh, on the wrong tab. Or what? So it's going to be debug for type. Yeah. Records, tag unions, functions have function at the beginning. It's not one of those. It definitely doesn't have this weird printout. I guess it could be an apply. Oh, that would make sense. I bet it's an apply. And this is where naming and type variables get weird, but you're applying the list type to its subvariable in order to define the final type of a list of some type. And so I think it's going to end up being an apply now that I look at their printouts and think about this more. So where's apply here? So it's right at the end here. So if we print the symbol, and why not the args as well? Now we may end up having an issue where I'll fix this for list, but it won't fix it for types that are built with lists, and so there may need to be some more proper, fancier fix. I wouldn't be surprised if that ends up being an issue. But what I'm gonna try right here is essentially just checking if the symbol happens to be the list symbol, and if so, just ignoring everything. And that will be like the cheapest, most basic form of a fix for this. It's really not proper at all, but I think it'll work. And the reason I say it's not proper is because like a dictionary is built out of lists, but I think it'll come up with a dictionary symbol here, and so like it wouldn't apply even though it should. Though not fully sure. Maybe applies smarter than that. Okay, so it has no args, and the symbol is node. Oh no, here we go. Yeah, symbol is list with the arg of a node. Perfect. So if we can just check that the symbol is list. I forget how symbols work. I think we should just have a list.list symbol, if I'm correct, real quick. If we head back down there. And so we go, I mean, do we have it imported? I think it's going to be, do I remember this? I think it's going to be all caps, but I don't think it's imported, so I have to figure out where it exists. Let me go to the definition here, and then go to symbol. Oh, it's probably just going to be symbol / list. Let's see, is there a list something here? Yeah. List equals list, etc. List. Yeah, that's what I'm going to want. Okay. So if we go back to where we were, so we're just going to start with the most basic solution. Is this going to work? Is it the symbol module that exposes this? We'll see. That's probably going to complain at us. Except, I guess we just want if it's... Oh, what did I just do? Tapped a weird button. Okay. That's really weird. My editor's acting up for some reason. When I hit the left button there, it like suddenly jumps. Okay, anyways. If it's not a list, do this thing. Otherwise, if it's a list, we will ignore that. And so if we do this, that may actually fix the bug, but not correctly. Oh no, symbol, undeclared. Oh, it might be like symbol list, something silly. Or it might be from the symbol tuple or something, and then I can't use not equals, I guess, for this. I need to do not matches, right? Oh gosh, right. So if the symbol does not match list, then we do all this stuff. Oh man, that exclamation point before and after looks really good. It looks really silly. Oh no, this is the symbol type. Where? Okay, why can't I get the list symbol? It exists here. What am I messing up that's not letting me import this thing? Yeah, symbol list is how it's used. Maybe it's just not imported, and I'm being silly. So be what? Symbol list. This is the most clear name ever. Okay, how do we not have symbol imported? It's literally right here. It's used by type. I mean, okay, we'll just import and move on. See if this imports happily. Anyways. Oh, it's roc module symbol. We'll just fully qualify this for now. That's kind of ridiculous. We'll import it later. Expected a reference to a symbol. We can just do that. They're copy friendly. That is such an ugly line, but I digress. We don't need that. Okay. So hopefully this will progress us in some way, shape, or form. Because we're basically saying if it's a list, just ignore the fact it's recursive, which is what we want to do, because lists are never truly recursive because they always have pointers. They don't mess with anything recursive. I have no idea the larger ramifications of this. This may actually be like some sort of huge mistake and very incorrect, but I'll have like IAs or someone else look at it later and they can tell me how silly I am. Okay. The body of this is a list of type list star, but they expect a list node. I mean, we at least didn't get the same error. That's something closer. I bet we have to like somehow resolve the alias if it's a list. This is going to be something really complex, isn't it? Real quick, just for the fun of it, if I do this, will that work at all? Like, so like, does just the base thing work? Like, I at least got something correct, right? Oh no, that is very angry. Oh boy. What happened? So we're now just generating totally invalid types or something. Layout from flat type for apply. Yeah, I get the feeling this is like actually something that needs fancy proper type system knowledge to fix. I'm picking all of the really hard bugs. Well, okay, the Rust glue bug was easy until I got to the fact that it had other broken things. But the rest of this was definitely beyond my pay grade. Because I don't really know our type system. Let's see if there's anything else useful I can do here. See you later, Luke. I think I may actually end this pretty soon just because I think it'll only just be me bashing my head into the type system if I continue. Yeah, I think that's probably the best. Okay. So yeah, I don't think I'm going to be getting through this type system bug because I think it is a much more complex thing and doesn't just work in the simple way that I was hoping it might work, which, I mean, I thought it was like a 50-50 whether or not the simple fix would be possible, but like this obviously has ramifications. Essentially what's happening here, if I understand correctly, is I've fixed the fact that it's a recursive type by saying ignore recursive list-based types. But now when it gets to final code generation and to other pieces with figuring out types, it's now like, wait, I don't know what this is. This seems like an incorrect type. And so it's not that we want to ignore lists. That's actually incorrect and why this is broken right now. I think we actually have to properly deal with them as cyclic aliases the exact same way that we deal with cyclic aliases for tag unions. And so what that would really mean is that like we still want them in that matrix, we still want to be checking for cycles, but we have to be smarter about it and not just say that, oh, it's a list symbol and oh, it's a node symbol. We have to say it's like a list or a node nested in a list. And so that counts as breaking the cyclic alias the same way as a tag union counts as breaking a cyclic alias. But I think that'll be much more involved to actually do correctly. But yeah, hopefully it's still useful to see someone attempting like a totally unknown section of the code base. Especially like I think the type system is, in my opinion, the most complex part of the code base overall. With that in mind, I guess any last questions that anybody wants to ask or any just different comments or thoughts. Otherwise, I think I will probably end this pretty quickly here because I don't think there'll be a lot of value in me continuing to try and figure out this type system stuff on stream, because I think it's one of those things that like either I need to go chat with someone who knows a lot more about it, or it's going to be, you know, hours of me tinkering so I can like actually understand the code, which is just, you know, too long for something to put on stream. But yeah, hopefully this was at least still a useful representation of what real rock work can be sometimes. You know, sometimes it's just debug prints and trying to understand some code that's rather complicated rather than anything more specific or interesting. Anyways, hopefully the stream was good for everybody, and I'll see you next time. Probably will go live again in, I don't know, a week from now, maybe something like that. When I do, I'll probably try to get a more like a better scoped problem so I can keep things interesting. But I will see everybody later. Enjoy the rest of your weekends, I guess, Fridays and then into the weekend.